Right. So welcome all, and so this video hopefully will be my last video where we'll talk about what to do when you have seasonality in the data. So this was the Tahoe salt data that I was showing in class the other day. So if I look at the demand values and if I look at a line graph, you'll clearly see that there is seasonality, right? So data starts in Q2 of year 1 and ends in Q1 of year 4. So basically we have for 3 data points for Q2, 3 data points for Q4, Q3, Q4, and 3 data points for Q1, right? And you'll clearly see that there is seasonality, right? So Q2, Q3, Q4, then Q1, Q2, Q3, Q4, Q1, right? So Q1 has the least amount of salt usage. Q4 has the most amount of salt usage, and then salt usage sort of increases. And not only that, there is generally an increasing trend. So not only is there seasonality in the data, there's also a generalized increasing trend in the data. So the question is, can we capture all of this at the same time? And that's what we're going to talk about today, all right? So what we're going to do is we're going to capture trends separately, and we're going to capture seasonality separately, and then we're going to use both of that to come up with a forecast, right? So how exactly is this done? So first thing that we'll do is we will figure out how much seasonality we have in the data. So to figure out seasonality in the data, what we do is we first find the total average demand. So you can calculate average demand. So you look at all the demand that you had, you average out all the demand that you have. That's a total average demand, right? So I'm just going to get rid of the decimal places. I don't need the decimal places. I'm just going to keep them. So then using that, what I'm going to do is I am going to calculate something called the seasonal factor. This is not the final thing that's going to help us with calculating seasonality. So it's a seasonal factor. We can calculate a seasonal factor, but seasonal factor is you take the demand and divide by the average demand, right? Seasonal factor, I'm just going to keep 2 decimals for this seasonal factor. I don't need more than that. Right, so seasonal factor is here, so I'm going to make that an absolute reference. Sorry about that. So just the denominator is $signs, the numerator is not. Otherwise, you'll get the same number throughout, right? Now, you'll notice that Q2 has a seasonal factor of 0.36 here, 0.45 here, and 0.54 here. So we'll finally calculate something called the seasonal index. And seasonal index is just one number for each season. And for each season is each quarter, right? So for Q2, the seasonal index is just the average of all the seasonal factors that you have. So it's going to be this seasonal factor plus this seasonal factor plus this seasonal factor divided by 3, right? We have 3 of them, so we're going to divide by 3. Again, I just want to keep 2 decimal places. There you go. So that's my seasonal factor. So similarly, I can do it for Q3. I can do it for Q4, and I can do it for Q1, and I only do it once, right? So I have one of these, one of each for each season. Now, a few things I wanted to notice. Now, all of these numbers will add up to 4 exactly, right? So what you're essentially saying is that if I look at the whole year's demand as a total, right? And if I divide it up equally into my 4 seasons, then my season, and if that would work, then my seasonal index would be 1, 1, 1, 1. So instead, what I'm saying is that in Q2, I'm only going to sell 45% of the average demand for the year. In Q3, I'm going to sell 66% of average demand. In Q3. In Q4, I'm going to sell 1.1 or 118% of average demand. And in Q1, which is the highest, I'm going to sell 171% of average demand, right? And all of these 4 will add up to 400 because 100%, 100%, 100%, 100%, right? So it adds up to 4. And the same seasonal index will get repeated. So once you calculate one set of seasonal indices, you don't calculate them anymore. It's the same number, just gets repeated again. So the simple way to do that is you just refer to the previous time and just copy this down. Okay. So these are my, that's my average demand, and these are my seasonal indices. One set of indices that get repeated again and again. Now, That was my seasonality. Now I have to capture trend in the data. So, but seasonality might affect this trend. So the first thing that I'll do is I'll do something called, I'll say deseasonalized data. So I'm going to strip seasonality out of the data and get rid of seasonality in the data. And spell it correctly, hopefully. DC. Why can't I spell today? D. SEASO. Deseasonalized data. So you're stripping seasonality out of the data. And how do you do that? You take any demand that you have and you divide by the seasonal index. That's your deseasonalized data. So I'm just gonna get rid of any decimal places. I don't want any decimal places in my demand. And there you go. And this number, you'll notice that is in general, sometimes it goes up and down, but in general is increasing, right? So even if I, let's say, inserted a line, you will notice that. Let me see if I can fix this. Okay. All right. So we sort of stripped everything out. Just the line is left. There's a little bit of seasonality left over, but you cannot always capture 100% of everything, right? Okay, so that's my deseasonalized data. So using this, I'm going to calculate my straight line. So what does my straight line look like? So there are two ways of doing this. One is if you go to data and if you go to data analysis, right here, my face is in the way. So you have something called regression analysis here. So you can use this regression analysis tool to do it. But that's, in my opinion, it's overkill for this. So what I'm trying to figure out is what is the straight line that sort of fits this data. So to do that, I need a y-intercept and a slope, and that's exactly what we'll calculate. We'll calculate something called the slope and the intercept, right? So slope is just slope. The formula is literally slope. And then you choose the deseasonalized data values and the time period values. Now these time periods have to be continuously increasing. You cannot use the year values or the quarter values. They have to be continuously increasing numbers, right? And then similarly, again, I want 2 million decimal places here. Two is good enough. And the intercept will be, again, intercept of the deseasonalized. So you cannot flip this, by the way. You have to choose the deseasonalized data first and the time next. All right. There you go. So once I have these two, so I have a straight line and I have the seasonal factors, so I can find my forecast. Right. So how do you do forecast? Forecast is first calculate the line. So you say y-intercept. So y. So remember, it's y is mx plus b. So m times x. X is the time period, right? Plus b, mx plus b. That's the slope, right? And you multiply this whole thing with the seasonal factor, seasonal index. So multiply the whole thing with the seasonal index. And that gives you the forecast for the time period, right? So again, I'm going to get rid of the decimal places. I don't want to see decimal places in my forecast. I'm going to go all the way down. Oh, where did I miss? Ah, right. So the slope and the intercept values always have to be in the same place. So I'm just going to make them absolute references, slope and the intercept. But the value of the time period and the value of the seasonal index will change. So I'm not going to put dollar signs for that and that. Okay. So these are my forecasts. So these forecasts not only include my increasing trend, but it also includes seasonality in the data, right? Then of course I can do everything. So I can calculate error. I can calculate MAD. So I can calculate error. For example, actual demand minus the forecasted demand, right? I can calculate error values. And I can calculate, say, absolute value of error and right. I can calculate MAD. This will be average, starting always here and ending, well, wherever it ends, right? You got that. And then I can calculate bias, right? It's just the sum of all the error up to this point. So it starts here again, ends in the same place. And then I can calculate the tracking signal. So tracking signal is bias divided by MAD. Go. And then I can decide whether if I have plus 3, minus 3, you'll notice that it went down below minus 3 once, again here, but then again it's staying mostly within the range. So you might say that the forecasting method is good enough. But the most important part is you can not only forecast for what is being done, but you can forecast for 1 year into the future, or maybe 2 years into the future. But the farther you go into the future, the worse your forecast is going to get. So let's forecast for 1 year into the future. So forecast for 1 year into the future, I will need time periods for 1 year into the future. So it'll be 13, 14, 15, and 16. So the next 4 quarters, right? So that's the forecast that I'm going to do. And I can calculate my forecast in the exact same way that I did, right? So I have my formulas and I have my seasonal indices, but I need to have another set of seasonal indices. So I'm just going to copy this formula down. So I get another set of seasonal indices. Now I can just calculate my forecast right there. So this here is my forecast for the next time period, right? So I'm saying that in the second quarter of year number 4, my forecast is 11,695. So the next is 17,534. The quarter after that, 17,761. And finally, the fourth quarter of year 5 will be 46,995. So this not only includes seasonality in the data that we had, but also that increasing trend that we noticed, right? That's it. And that is how you incorporate seasonality into the data, right? Okay. So I'm going to end this video here, and this has been 4 videos talking about basic forecasting methods, exponential smoothing methods, the error analysis, and what do you do when you have seasonality in the data, right? Okay, I'm going to end this here. So there is a whole section in the textbook that talks about regression analysis, multiple regression analysis, all of that. I guess we didn't have time to go over that, so I'm just going to stop it. Okay, take care.